measuring currents using an ammeter. Measuring currents using an ammeter. The diagram here is just an illustration of how currents can be measured using an ammeter, okay? Oh yes, it illustrates how we can measure current. Look at it. This diagram you're looking at illustrates how currents can be measured using an ammeter, okay? And we begin by saying that we can only measure currents but by first of all connecting the following components. The first one is lamp, the second one is the ammeter itself, the third one is a source of energy, maybe a cell or a battery, but in this case we are using a cell and then a switch. All right, so that is it. If we do that, we have come to understand that our presentation here is all about trying to get the picture of what we're trying to do, okay? So I just did that to illustrate that this diagram is what we're going to use to illustrate how currents can be measured using an ammeter. So the first thing we need to do here, in case we are asked as students, as learners, how does current, or how can we measure current? All right, we can as well. All right, the topic we are going to consider today is measuring current using an ammeter. All right, that's the topic we are going to consider today. An interesting topic in physics, and it's very simple if you understand the concepts involved. So what we're going to do is very simple. First of all, look at this. Let me illustrate this. This diagram that I am circling, or rather covering with a square shape, illustrates how a current flowing in a metallic conductor can be measured using an ammeter. For instance, we need to understand that an ammeter is an instrument that measures small amount of current. All right, this ammeter is an instrument that measures small amounts, no matter how small the current is. Ammeter is the instrument that measures such. Now, how can we measure the current flowing in a metallic conductor or in a circuit? It's very simple. The diagram here illustrates that. Says that we have to connect these following components. How many components do we have here? About 4 components. The first one is lamp. The second one is the ammeter itself. And then we take it to this point. We have a source of energy known as a cell or a battery. But in this case, we are looking at a cell. And then the last one, not the least, is the switch. Now we have understood the various components that we need for us to be able to connect this and be able to measure the amount of current flowing in an electric circuit. All right, so the next thing we need to do here is very simple. Let's quickly remove these arrangements. Okay, we now have a plain diagram illustrating that. So this is the ammeter. Okay, let's take our point again. This is the ammeter, right? This is the ammeter. This is the lamp. This one is the switch, and then finally this is the source of energy, maybe a cell or a battery. All right, so how is it measured? Very simple. To measure currents in an electric circuit, the ammeter, look at this, the ammeter is connected in series with the lamp. We must understand that for you to be able to measure the amount of current flowing in an electric circuit, you must connect ammeter and ammeter in series. Look at it, in series with the lamp, so that as soon as the switch closes, energy is supplied into the lamp, And the amount of current flowing will be measured by the ammeter. So that's what it means. Current is measured using an ammeter, all right? Look at this. Current is measured using an ammeter. That's the first statement here, okay? No matter how small the current is, the device or the instrument that will measure it is an ammeter. Then to measure this current according to our statement here, the current through a component, the ammeter, must be placed in series with that component. The ammeter has to be placed in series in that component. Alright, so the question now is, now we have understood that current can be measured by connecting an ammeter in series with the lamp. We want to know the amount of current that has been measured. All right, suppose we have here, according to what we have here 12 volts. All right, we have maybe 12 volts, 12 V, representing the source of energy, and then the resistance offered here is just 0. All right, I want to illustrate something 0.5. Okay, we have 0.5. Okay, 0.5 is the amount of resistance here. Resistance measured in ohms. Okay, good. Now we don't know what's the current. We don't know the current flow. Okay, we don't know. Current is question mark here. All right, we don't know the current flowing into the system. So how do we find it? Very simple. That's what the question is all about. Says if a lamp resists the current flowing through it by 0.5 ohms when the cell of 12 volts is connected, estimate the value of the current flowing around the circuits. Okay, it has been solved already and we have 24 amps. But how can a child understand this? All right, so we are going to solve it once again, and then you are going to see how this can be done and done very well. All right, let's begin our solution. We're going to use this side to say our solution. Okay, our solution is going to be very simple. We don't need to waste time because it will help us to cover a lot of things here. Our solution is going to be that we are looking for current. So current is unknown. Current is unknown. Current is represented by letter I. So current here is unknown. That's what it means. Current is quite unknown here, right? Good. So the next thing we are going to take, we are just fishing out what we have in the question. So our source of energy, potential difference across, or EMF, or voltage across, the energy across or supplying across the lamp is 12 volts. So we write it down, 12 volts, 12 volts. Okay, good. Now the next one, we need to consider resistance offered. Okay, that lamp offers some amount of resistance given at 0.5 ohms. Okay, this is 0.5 ohms. So we are going to put it down there for clarity purpose so that we don't get confused while solving. All right, so this is 0.5 ohms. Good, that's the symbol for ohms. Now it's time for us to apply the appropriate formula in solving this. So what do? We write down the formula. The formula we are going to use to solve this, all right, is very simple. We put it down. Formula is FOR, all right. The formula we are going to solve this is Ohm's law, right? Yes, that's the formula we are going to use to solve this, and that will help us a lot to understand what Ohm's law is all about. By the time we do this, the picture will come out clearly. Very good. The formula now is Ohm's law, which states that energy is given, all right? The source of energy, potential difference, is directly proportional to the current, and then certain other things remain constant. So we have this, I, okay, I is the letter representing current, then R is the letter representing resistance. So this is the Ohm's law, right? But in this question, we are looking for the value of the current. Look at it. We are looking for the value of the current that has been measured by the ammeter connected in series with the lamp. All right, so what do? The letter for current is I. We are going to make I the subject of our concern, the subject here. So I is equal to E, right? Then I is equal to E all over R. Good. So that's what we're going to do. All over R. The next thing, we substitute. And by the time we substitute, we find the remaining aspect of our distance. So how do we substitute? Quickly, we substitute. The value for E is 12 volts, right? The value for E is 12 volts, okay? All over. The value for R is 0.5. 0.5, okay? 0.5. And that gives us, how do we solve this now? Very simple. We are going to simplify this further so that you understand how we got 24 amps in the first place. All right, very interesting. So what we do is going to be 12 all over 1, right? Good. Times, all right? What comes up here is going to be 10. We have 12 all over 1. Let's make a big use of our eraser so that we remove what we don't want and then stick to letters we need. So what comes up is 10, all right? 10 all over 5. Yes. Of course, 0.5 simply means 10, 5 all over 10, but because we have converted using multiplication sign, it's going to be this way. Therefore, the next thing we are going to have here is a simple multiplication concept, whereby we have 12 times 10. I repeat, 12 times 10 is going to give 120. All right, it's going to give us 120. Good. All right, 120 all over 5 times 1 or 1 times 5 is going to give us 5. All right, good. And then we now have 120 divided by 5. Very simple. Very simple. So you can see how we can solve to get the value of current being measured by this ammeter, and the value of current by the time we say 120 divided by 5, we have 24 amps, okay? 24 amps. That is what it means, all right? Ampere, that's what it means. A stands for ampere, right? And that is the unit of time. So this is the answer. This figure is the answer, and that's what you can see. They arrive at 24 amps. Therefore, when an ammeter is connected, right? When an ammeter is connected, look at it very well. Just look at it very well. You see it's connected in series. The amount of current flowing after some amount of resistance is offered 0.5 ohms from this source of energy, 12 volts, 24 amps, okay, is measured by the ammeter. So that is what it means. Very simple, right? This is interesting. So with this, we have now learned how to measure the amount of current flowing in an electric circuit and how to calculate the current itself using some amount of formula, Ohm's law. This is called Ohm's law, right? We are going to come to that in detail as time goes on. But I just want to use this privilege to teach how 24A or 24 amps was obtained in the first place. I hope this is okay. All right, let's look at, before we continue, remember to subscribe, okay? Give us some thumbs up, okay? Click on the bell button for constant notification. Each time something like this is uploaded, you will be among set of individuals that will be notified. Don't forget, please, to share to your friends, to your numerous networks, to students that need this. Who knows, you might be helping someone somewhere there. All right? Okay, that is for that. And we are going to move on to the next.